Hi, I'm Carrie Phelps, Director of Product. At Weights and Biases, our mission is to build the best tools for machine learning. We're constantly getting new insights from the real-world ML teams who are using WMB to get better models in production. We worked with experts at OpenAI and other industry-leading teams to understand their key pain points. Every industry is starting to build machine learning teams in every vertical. This diagram is from a few years ago. The latest diagram of companies using ML in the real world is so large, it hardly fits on this slide. The industry is exploding, but standardized tools and workflows aren't keeping up. There's a tectonic shift between the software workflow and the ML workflow. There are tools for every stage of software development, but there are no clear standard tools for the ML workflow. We're missing a standardized industry process for moving models from training through production. What does a sample machine learning workflow look like? In the data curation stage, teams are starting with collecting and labeling raw data. Then, exploring and cleaning the data. Then they're preparing and transforming that data into trainable sets. There is critical metadata produced from the process of data curation. You want to be able to track the raw data, the pre-processing code. It's important to see when that pre-processing code changes, because it has implications on the format and content of the datasets that then feed into the rest of the pipeline. You care about the training dataset that was produced by the dataset preprocessing step. When you split the data into training and evaluation, you want to capture the exact evaluation set, so those examples aren't leaked to the model during training. The next stage after data curation is modeling. That starts with quick, iterative experimentation. A machine learning practitioner is hacking around in a notebook, trying different architectures and hyperparameters, and running lots of experiments. Then they're evaluating and optimizing those trained models, seeing how they perform on different held-out test sets, and running hyperparameter sweeps to optimize the model and squeeze out a next level of model performance. That process also produces data exhaust. This includes training metrics, which compares how models perform. Model checkpoints to capture each stage of training and associate the exact model weights with the metrics. Engineered features with custom transformations of raw data that might change as the team learns more about the problem space and iterates on features. The environment where the model was trained, including hardware, Python version, any installed requirements. Terminal logs are often lost to terminal history, but especially when debugging, it can be very useful. You want to be able to scroll back for a given model and view all the command line messages and warnings. System metrics can help identify opportunities for optimizing model training. For example, was this model running out of memory during training? Were there issues with the GPU or CPU? What about network requests? What were the bottlenecks from the hardware side that might have affected the model training process? Training code. When you edit a hyperparameter and quickly run a script again, that change isn't committed to Git. It can be really hard to get the exact state of the code if there's not a system picking up uncommitted code changes. It's critical to have the exact version of training code, including any uncommitted changes in a diff patch. Evaluation results help us understand how does the model perform on different test sets. Were there two models evaluated on the exact same test set? Sweeps. Did someone on the team run a Bayesian search to find the best hyperparameters? What combinations of hyperparameters have we already tried? Massive sweeps can be expensive, so it's critical to track what you've tried already, so you're not wasting GPU time. And finally, we make it to the deployment stage with our trained model. First, the model is packaged up and productionized. That could be the same team of ML practitioners, or in many cases, that's a new team of ML engineers focused on reliability and performance in production. There's also serving and monitoring. Make sure that the model is performing well in production. Monitor statistics like time to inference, and identify when the model is experiencing significant drift. The deployment stage produces its own set of key data to save and monitor. How is the model packaged up? What is the model seeing in production? How are real-world inputs and predictions differing from the training and evaluation stages? Is there drift? Was the model trained on a dataset that has a different class distribution from the real-world inputs? What are the performance metrics, and how are they changing? We want to see metrics over time to identify shifts in model performance. When is the right time to update a model in production? Alerts are critical for identifying model regressions and triggering processes to update the production model. This machine learning workflow is iterative and cyclical. Once it's set up, stable, and tracked, teams will run that process again and again. Getting the best model is a matter of iterating quickly, reacting to changes in the real world. We know that the untracked processes are brittle. Here's a screenshot from Stack Overflow from a few years ago, before everyone in software was using Git. This person is asking, why should I use version control? Why not just duplicate the script and name it version 2, version 3, version 4 of final? Before version control became a standard part of software development, it wasn't obvious how critical it would become. The machine learning workflow is in a similar place today. We have this whole host of critical metadata and context for data curation, modeling, and deployment. And today, I'm making the case that you need comprehensive tracking to have an effective machine learning pipeline. Here are a couple of case studies to highlight how real-world WMB users are tracking their workflows. When we started working with OpenAI, they were working on a robotic hand to solve a Rubik's Cube. This is a hard problem with a lot of moving pieces. Even starting with a simpler problem of manipulating a solid cube without dropping it, it's really hard to train a model to do that effectively. It requires a lot of coordination, and they had many, many trials that failed, many experiments that they learned from. Multiple team members were training models in parallel, and before WMB, they had trouble communicating results. It was hard to capture and compare iterations of model training. What was this test accuracy? How long did this model take to train? What environment version was it using? Have you tried a lower learning rate? There were a flurry of Slack messages back and forth to communicate findings. And these details and context from modeling were hard to track without a dedicated system. OpenAI needed to make fast progress on production models, and they needed tools for tracking and iterating. Another one of our favorite customers to work with is Blue River, part of John Deere. Their goal is to use machine learning in agriculture, scaling up processes that are too slow and manual for a human. A little background on the problem space. Farms operating at a massive scale need to kill weeds fast. For example, when growing cotton, the weeds can compete for light and water and stunt the growth of the cotton plants. You can see this here in this comparison between the left, a field with weeds that are slowing the growth of the crop, and on the right, where weeds have been sprayed and the cotton is flourishing. When you're spraying a whole field of crops, this can produce a lot of chemicals that run off the fields. But what if you only spray the weeds? Well, that's a hard problem. Can you tell which plants on this slide are weeds? To me, the crop here in green and the weeds in red look almost the same. But Blue River is building a solution, an expert model that can spot weeds in fields. They drive tractors with GPUs on the back of them through fields and run models in real time to identify where the weeds are. Then, carefully, they only spray the weeds. This is an amazing application of machine learning and a very challenging workflow to manage end to end. They've got live data from different sources, real fields where their models are deployed. Data comes in from different times of day with different expert labelers, different crops and environments. They need to manage these constantly changing data sets. They need to track models trained in different conditions. And it's hard to stay on the same page when your team is operating in different fields. They need to track how changes to data upstream affects model performance downstream. OpenAI and Blue River are two examples of the hundreds of teams we work with across industries who have complex workflows. They need tools to not just track individual models, but capture the complete history of where a model came from. Looking across our customer teams, we've compiled a short list of best practices, common traits of an ideal ML workflow. One of the teams we work with at W&B is a group of ML practitioners at a national bank where they're deploying models to identify fraud. Models need to go through multiple stages of checks and audits by different teams before they make it to production. And this can be a complicated and multi-week process. Our key takeaway is that every step of the pipeline needs to be auditable by internal and regulatory stakeholders. And that audit trail needs to be captured automatically. A large team we work with has expanded to over 100 models in production, and they're constantly onboarding new team members. To keep up with the demand, they need to be able to run and rerun every detail of the pipeline automatically. If someone leaves the team, the knowledge doesn't leave with them. Their model workflows are reproducible, so all the critical details are captured in a central system of record. One of our customers is running a popular generative model. Type in text and get a generated image. They're getting a massive number of requests, and they collect feedback on whether the users are satisfied with those generated images. They constantly need to retrain and tune the model to push a new version to production. Their workflow needs to be iterative, so they can quickly update components and rerun the pipeline without much manual intervention or overhead. An autonomous vehicle company we work with has multiple teams working on different problems, like perception or path planning. It's dangerous to have these teams siloed. They all need to be on the same page about changes going into the car. Their workflow is necessarily collaborative, and it's critical that the tools they're using support sharing and communicating about results. One of our customer teams in healthcare is working with patient data, and they need to stay HIPAA compliant. Their ML workflow needs to be enterprise-grade, highly secure and stable, to protect their mission-critical, sensitive data. And finally, one of our customer teams is deploying models for Formula One racing. They need analysts on the ground to be able to run and analyze the results of models in real time. Their model workflow needs to be incredibly accessible, with a visual, interactive, and friendly user experience. We're using these key principles of ML workflow best practices to inform the tools we build in our MLOps platform at W&B. This is going beyond experiment tracking. We're helping teams build an end-to-end, standardized process, from fresh data all the way to fresh models in production. How do you scale up the process of iterating on models, centralize the knowledge of complex pipelines, and automate repeated stages? With our new tools for model CI/CD, you can standardize and automate your workflows and ensure that every model going to production has been rigorously tested and tracked. When did this model move into production? Who signed off? With the model registry, see a clear, auditable history of every change to models moving through workflow stages. See exactly who made a change and when every change occurred, and easily click back to see all the details of each model version. What was the exact version of the dataset that this model was trained on? Are there two models that are being evaluated on the same exact test set? Add WMB to your pipeline once, and every time you run your training workflow, you'll be capturing a full, reproducible lineage. What happens when something goes wrong? Say you discover a bug in your data preprocessing code. How can you find all the data sets that were affected by that bug? How do you track down all the models that were trained using those data sets? With the model registry, it's easy to see all the steps upstream and downstream. Start from a central page that captures all the model versions you've iterated on for a given model task. Compare model versions and easily get back to where a given model came from. Click through to see the run that produced a model and the metrics and code associated with that model. Are there multiple evaluation steps? The reproducible lineage gives you a clear way to track dependencies, debug pipelines, and handle regressions. We know that the best way to get a new model to production is to have a repeatable process that allows for quick iteration. Use WMB to automatically trigger model retraining when new data is available. Set up a trigger in that same central dashboard where you're managing models. Trigger model evaluation jobs every time a new candidate model is registered. Ensure that all the models you're comparing were evaluated on the same test set, and that the comparison is really apples to apples. Reduce the manual work and cognitive overhead for iterating with automated tooling. Keeping team members on the same page is hard when there's lots of moving pieces in the ML workflow. With the collaborative dashboard for models, it's easy to see what model is in staging or in production right now. Answer questions like, how does my new candidate model compare to the one my colleague currently has in production? Without a lot of back and forth. We developed our tools for model evaluation and model management with the enterprise in mind. We support private hosting to meet rigorous security requirements. Customers with their own secure clusters use WMB to automatically trigger model retraining on their own compute, and use WMB for enterprise-grade model CI/CD. Once models are rigorously evaluated, use WMB to package and deploy models to production. Our tools for deployment are customizable to suit the rigorous requirements of enterprise model serving. Run a customized job straight from the model management dashboard, or trigger the job automatically to run in your own system. Customers are using WMB to standardize model deployment, so the system for keeping models up to date can scale as their team grows. And finally, WMB makes it accessible to manage and evaluate models. With a single, central home for all your production models, your whole team can easily see the current state of production, upcoming candidates, and how they compare. Customize the stages that models move through, and track when a new candidate moves from staging to production. You can build a centralized model zoo to share and communicate about the best models available for different tasks. And with WMB, you can make it accessible for non-technical stakeholders to even trigger model retraining or evaluation themselves from that same unified dashboard. Our vision is an end-to-end developer-centric MLOps platform. We are building modular tools to solve pain points across the ML workflow. Use the WMB MLOps platform to version data and pipelines with artifacts, prep and visualize data with tables, track model training with experiments, optimize models with sweeps, test and evaluate with the model registry, and collaborate and share results with reports. The ML industry is moving so rapidly, teams need a comprehensive system for model management beyond experiment tracking. With our new tools for model evaluation, you can start tracking and automating the full model lifecycle. Capture dataset versions and visualize example-level model predictions. Track models as they move to production with complete lineage and history. Coming this year, we'll be offering production monitoring for deploying models to close the loop from training to production. And finally, I'm excited to announce our new products, models, and launch are now available for you to try. Try this quick guide to get started with Model CI/CD and help your team deploy better models faster. We're so excited to see what you'll build.